In this video, we will learn about common protocols of 6LoWPAN application. Students will be able to identify efficient protocols of 6LoWPAN based on application. Common protocols. This section introduces protocols that are commonly used or have good potential for use over 6LoWPAN. This include Web Service Protocol, MQTT, SIGBee, CAP, Service Discovery Protocol, SNMP, RTP or RTCP or SIP, and industry-specific protocol. The web service concept is hugely successful on the internet, especially in enterprise machine-to-machine internet system, as many backend systems incorporating information from low-PAN device will already be using existing web service principles and protocol. It is expected that 6LoWPAN will be integrated into the web service architecture. Web Service Protocol. The web service concept is hugely successful on the internet, especially in the enterprise machine-to-machine internet system. The web service are simply URLs available on the HTTP server with service or resource accessible behind them. The figure shows the typical structure of web service content, which is always built upon HTTP and TCP as used today on the internet. This service may support many number of methods with corresponding response that are described by WSTL document. Resource-based web service can also be realized using a set design. In this model, formal message sequences are not used. Instead, each resource is identified by a URL. By using different HTTP method on that URL, the resource can be accessed. In the gateway approach, a web service gateway is implemented at the edge of the LoWPAN, often on a local server or the edge router. Inside the LoWPAN, a proprietary protocol is used to request data, perform configuration, etc. The gateway then makes the content and control of the device available through a web service interface. In this approach, web service actually end at the gateway. This technique is widely used with non-IP wireless embedded networks such as ZigBee and vendor-specific solution. Compression approach. In the compression approach, the web service format and protocol are compressed to a size suitable for use over 6LoWPAN. This can be achieved using standard and has two forms, end-to-end and proxy. The end-to-end, the compressed format is supported by both application endpoint. In proxy, an intermediate node performs transparent compression so that the internet endpoint can use standard web service. This is MQ telemetry transport for sensor network. The MQ telemetry transport is a lightweight published subscriber protocol designed for use in the enterprise application over low bandwidth wide area network links such as ISDN or GSM. The protocol was designed by IBM. The MQTT uses a broker-based public or subscriber architecture to which clients publish data based on matching topic names. Subscriber then requests data from the broker based on topic names. Although MQTT was designed to be lightweight, it requires the use of TCP and the format is inefficient over 6LoWPAN network. In order to allow for MQTT to be used as also in a sensor network, MQ telemetry transport for sensor network was developed. This optimization protocol can be used over ZigBee, UDP, or 6LoWPAN or any other symbol network providing a bidirectional datagram service. MQTT's architecture. It is made up of four different elements: MQTT brokers, gateways, forwarders, clients. Clients connect themselves to a broker through a gateway using MQTT's protocol. The gateway may be located on the LoWPAN edge router or it may be integrated in the broker itself, in which case MQTT's messages are simply carried end-to-end over UDP. Gateways translate between MQTTs and MQTT. In case a gateway is not directly available, forwarders are used to forward messages between clients and brokers. Forwarders may not be needed with 6LoWPAN as UDP datagram can be sent directly to a gateway. Protocol operation. MQTTs include a gateway discovery procedure which does not exist in MQTT. Alternatively, clients can be pre-configured with gateway location to avoid discovery overhead. Gateways send periodic advertised message and clients may send messages. Client connect to a gateway which responds with an acknowledgement. Disconnect is used to end a connection or to indicate a sleep period. Client can connect with multiple gateways which are able to perform load balancing. Gateways can function in either transparent mode or aggregation mode. In transparent mode, where a connection to the broker is maintained for each client. Aggregation mode, where the gateway aggregates messages from all clients into a single broker connection. Combat Application Protocol, a solution for using Zigbee Application Protocol and Profile or UDP IP, especially over 6LoWPAN, has been proposed. This specification defines how the CTL is mapped to standard UDP or IP primitives, enabling the use of any Zigbee profile over 6LoWPAN or standard IP stack. The function of SAL and SHCL are implemented by the CAP. The data protocol corresponds to the Zigbee cluster library. The management protocol corresponds to the Zigbee device per profile handling, blinding, and discovery. The CAP protocol stack is shown in the figure. The security protocol implements Zigbee application supplier security. Any Zigbee public or private application protocol can be implemented over CAP in the same way that it would use the native Zigbee. This allows for Zigbee application profile to directly be applied to IP networks.